So, hi, we are going to the second part of this reformulation, the physicochemical characteristic. So, as you can see, we have about 7 parameters that we can look here: the physical appearance, polymorphism, stability, solubility, vaporization and melting point, membrane permeability, as well as pH and pKa. Right. As for the physical appearance, it involves the visual characteristic of a drug substance, such as its color, its odor, its texture, its particle size, and it provides initial information about the purity and the quality of the substance. So usually when we examine the physical appearance, we got the initial assessment of the drug substance. Any abnormalities or unexpected changes in appearance can signal potential issues with the synthesis or the storage of the product. Yeah. So, for example, we have the liquid here, highly volatile, not stable, so physically sealed to prevent evaporation. So, is it possible to formulate liquid form of a drug to tablet? However, that mostly involve a chemical modification. So, usually because we know that the most stable part is the solid, because it is the less difficult to formulate. Um, so if you have liquid here, you know that it is not quite stable. If possible, you want to convert it into a tablet with some modification, for example, by the addition of the nitroglycerin. In terms of this vaporization and melting point, this is the temperature at which the substance transitions from the liquid to a vapor. It is particularly relevant for volatile substances, and the melting point is the temperature at which a solid substance transitions into liquid. So, why is it important? These 2 points are crucial to determine the appropriate conditions for the processing and the manufacturing of your drug product. So they influence the selection of suitable excipients and other manufacturing techniques. In pre-formulation, understanding these points will help to ensure that the drug substance can be processed and formulated without compromising its one, stability, and two, its efficacy. Okay. Now we go into the stability of the component. So solubility, permeability, chemical and metabolic stability affect the bioavailability of the drug. It means how long it can stay or being absorbed to your body. So stability encompasses of these elements, the chemical and the physical integrity of a drug over time. It involves considerations such as degradations, um, the oxidation, the susceptibility of the drug to environmental factors like the heat, light, and moisture. And it is significant for us to know the stability of a drug so that we are able to formulate product with a suitable shelf life. The pre-formulation study will evaluate the drug stability under various conditions, helping to choose appropriate packaging and storage conditions, as well as guiding formulation decisions to enhance its stability. So if you have your solid drug here, uh, if you desolute it will become the drug in solution through the membrane sulfur, absorb the drug, and then the drug's been extracted and it's been sent to the systemic circulation of your body. So it involves all this stability before it can reach the whole body system, right? In terms of the solubility of um, the drug, it usually refers to the ability of the drug substance to dissolve in a solvent. It is critical parameter because it influences the bioavailability of the drug. Poor soluble drugs may have limited absorptions in the gastrointestinal tract, affecting their therapeutic efficacy. Right, temperature-dependent solubility refers to the phenomenon where the solubility of a solvent, uh, of a substance in a solvent, changes with variations of temperature. In general, for many substances, the solubility increases with an increase in the temperature for solids in liquid solvent. And you can see the factors influencing temperature dependent solubility. The first one is the whether or not the process is endothermic and exothermic process, i.e. heat absorbed or heat released during the dissolution process can affect the solubility. The second factor is the entropy changes, changes in the molecular organization of the solute and solvent during dissolution. I'll give you an example. Consider dissolving sugar in water. At higher temperatures, more sugar can dissolve because the process is endothermic, requiring heat. Okay, so what's the difference between endothermic and exothermic process? I think this is a recap from for you. An endothermic process absorbs heat from its surrounding. In the context of solubility, these endothermic dissolutions occurs when the dissolutions of the solute requires an input of heat. For example, the dissolutions of ammonia nitrate in water is endothermic. It absorbs heat from the surrounding, causing the solutions to feel cold. Meanwhile, the exothermic um, reaction or process releases heat to the surroundings. In the context of solubility, the exothermic dissolutions occurs when the dissolutions of the solute releases heat. So you can see here, it releases the heat. Hence, the solutions feels warm to your hand if you're doing it in the lab. So relationship between temperature, solubility, and endothermic or exothermic processes. For many solids dissolved in liquid, the dissolutions process is endothermic. Increasing the temperature provides more energy to overcome the attractive force, to overcome the attractive force between solid particles, making them more soluble and then hence you will feel it cool. However, there are exceptions. For some substances, solubility decreases with increasing temperature due to competing factors such as changes in the entropy. So the key points that we want to highlight here, endothermic dissolution tends to result in increased solubility with the increased with increasing temperature. Meanwhile, the exothermic dissolution tends to result in decreased solubility with the increasing uh, temperature. Therefore, understanding the temperature dependence of solubility is crucial um, in various fields. For example, this pharmaceutical for the drug formulation, or even the chemistry and the environmental sciences, where it all influences the process, like crystallization, precipitation, and the chemical reactions. So we must consider this principle when designing processes or formulating products, where they are depending on the solubility as a critical factor. And next, we have this factor of merit parameter of polymorphisms. Basically, polymorphism refers to the ability of the substance to exist in a different crystalline form. Different polymorphic forms of a drug may exhibit variations in the property, such as the solubility, dissolution rate, and stability. The polymorph are chemically identical, but they have different arrangement of the crystal lattice. Hence, they are giving different energy. They have different melting points, solubilities to solutions, and many others. The different intrinsic solubility and dissolution rates may lead to different absorption, which implicate the therapeutic potential. And so the significance of polymorphism when we are doing the formulation is we want to investigate the polymorphic drugs, the polymorphic form of the drug to select the most suitable form for formulation. The choice that we make can impact the bioavailability and the overall performance of the drug. So it's between the stable form or the metastable form. These are the example of the drugs that exhibit polymorphisms. So you can see steroid, barbiturates. So we have acetaminophen, just like these paracetamol, and we have many other. More examples that we have here is the chloramphenicol palmitate. This is used to treat bacterial infections. So you can see it exists in polymorph, having a stable and metastable forms. The meta form of the drug, if formulated as suspension, was always found to have higher solubility, dissolution rates, and absorption compared to the stable form. And you have this methylprednisolone for treating the inflammation. Also exists as metastable and stable forms. The drug formulated as a suspension for subcutaneous injection containing the two crystalline forms provide a sustained release of the drug, where the metastable form, being highly soluble compared to stable form, can provide a rapid initial dose. Yeah, while the stable form will be slowly dissolved after that. So imagine if you have two items or two polymorph of the same treatment, therapeutic treatment information. You have the first metastable will release its impact and then giving a faster therapeutic impact, and then will be carried out by the stable form that will prolong the overall actions dose, which called the maintenance dose. Okay, we are done for the first part. We will continue the pH in the second or in the next video. All right, thank you.